Welcome to all. This is Srinivasan, Assistant Professor in Mathematics Department, Isayaram College of Engineering. Today we will discuss the topic is module number 3. The topic is Z transform. So already we explained clearly what is meant by Z transform and we discussed problem based on Z transform. Now we discussed the inverse Z transform and problem based on inverse Z transform. We will discuss one by one. So what is meant by inverse Z transform? So inverse Z transform is if Z into f of n equal to capital F of Z. So Z transform of f of n equal to capital F of Z, then f of n is called the inverse Z transform of capital F of Z. It is denoted by Z inverse of capital F of Z equal to f of n. So this f of n is called Z inverse of capital F of Z. Okay. So before going the problem, we'll discuss some important formula. Already we explained what is z of 1. Z of 1 is z divided by z minus 1. So here inverse z inverse of z divided by z minus 1 value is 1 and z inverse of z divided by z minus a value is a power n and z inverse of z divided by z minus 1 the whole square equal to n. The meaning is the z of 1 value is like this and z of n value is like this. Okay, that is the z transform. Here inverse z transform. Okay, so we will discuss the problems by one by one. So the first problem, to find z inverse of nz divided by z square minus 3z plus 2. So by the definition, by the inverse z transform inverse definition, z inverse of capital F of z equal to f of n. So clearly this is capital F of z. So capital F of z equal nz divided by z square minus 3z plus 2. So tan z divided by, so the solution is the root is z minus 1 into z minus 2. Then taking z outside, we get capital F of z divided by z equal to 10 divided by z minus 1 into z minus 2. Now we use the normal partial fraction method. We get 10 divided by z minus 1 into z minus 2 equal. I will write this equation a divided by z minus 1 plus b divided by z minus 2. Then we get 10 equal to a into z minus 2 plus b into z minus 1. Now replace z equal to plus 2, we get b value. And put z equal to plus 1, we get a value. So by using these two terms, we get a equal to minus 10 and b equal to plus 10. This and a, b value substitute in this equation, we get 10z divided by z minus 1 into z minus 2 equal minus 10. A value is minus 10 divided by z minus 1 plus 10 divided by z minus 2. Here 10 is common. Taking outside, we get 1 divided by z minus 2. This is the positive term. So I will write the first 1 divided by z minus 2. And the negative term is minus 1 divided by z minus 1. So what is 10 divided by z minus 1 into z minus 2? That is capital F of z divided by z. So capital F of z divided by z equal 10 into z divided by z minus 2 minus 1 divided by z minus 1. Now this z multiply inside, we get z divided by z minus 2 minus z divided by z minus 1. Now taking z inverse on both sides, we get z inverse of f of z equal to 10 into z inverse of z divided by z minus 2 minus z divided by z minus 1. So by the definition, z inverse of f of z equaled small f of n. That is the inverse z transform. So the z inverse of capital F of z value is f of n, that is equal n into. Now I substitute z inverse in each term. So z inverse of z divided by z minus 2 minus z inverse of z divided by z minus 1. By the inverse formula, we know z into z divided by z minus a, z into a power n value is z divided by z minus a. Here a equal to 2. So z inverse of z divided by z minus 2 value is 2 power n minus z inverse of z divided by z minus value is 1 power n. So 1 power n is 1. So this is our required solution. The next problem. To find z inverse of z cube divided by z minus 1 whole square into z minus 2. Clearly by the inverse definition, Z inverse of this is capital F of Z. So capital F of Z equal to Z cube divided by Z minus 1 whole square into Z minus 2. From this Z cube, I take Z outside, we get capital F of Z divided by Z equal to Z square divided by Z minus 1 whole square into Z minus 2. Now apply the normal partial fraction method. We get a divided by z minus 1 plus b divided by z minus 1 whole square plus c divided by z minus 1. Then cross multiplication, we get z square equal to a z minus 1 into z minus 2 plus b z minus 2 plus c z minus 1 the whole square. Now replace z equal to 1. So put z equal to 1, we get b value. Put z equal to 2, we get c value. And compare the coefficient of z square on the both side. So 1 equal to, see here, compare z square, a is contains z square and c is contains z square, b is not contains z square. So a plus c. So z square equal to a plus c. And here compare the coefficient, 1 equal to a z square plus c z square, the meaning. So z square equal to a z square plus z square, we can compare the only coefficient. So 1 equal to a plus c. And a equal to 1 minus c because we know the c value. So 1 minus 4 equal to a equal to minus 3. Okay. Now substitute a, b, c value in the equation. We get minus 3 divided by z minus 1 plus minus 1 divided by z minus 1 whole square plus 4 divided by z minus 2. And these two full values, we take f of z divided by z. So taking z, multiply z in inside, we get minus 3 into z divided by z minus 1 minus 1 into z divided by z minus 1 whole square plus 4 into z divided by z minus 2. What is capital F of z? Okay, this value is the capital F of z. Now taking in z inverse on both sides. So z inverse of f of z equal, in I multiply each term in the z inverse. So taking z inverse, inverse z transform on each term. What is, by definition, z inverse of capital F of z equal to f of n. So f of n equal to minus 3 by the formula z inverse of z divided by z minus 1 value is 1 power n minus z inverse of z divided by z minus 1 whole square value is n plus 4 into z inverse of z divided by z minus 2 value is 2 power n. So this is 4 into 2 power n minus n minus 3. This is required solution. So next problem also same procedure. Take the capital F of z, that is z square divided by z plus 2 into z square plus 4. Here taking one z outside, we get capital F of z divided by z. By apply partial fraction method, we get the equation a divided by z plus 2 plus bz plus c divided by z square plus 4. So the equation is z equal to a into z square plus 4 plus bz plus c into z plus 2. Now substitute z equal to minus 2, we get a value, and z equal to 0, we get c value. So a equal to minus 1 by 4, c equal to 1 by 2. Okay. So next we have to find b value. As usual, same procedure, compare the coefficient of z square on both sides. So in the left hand side there is no z square, so 0 equal to a plus, 0 equal to a plus b, b equal to a minus, b equal to minus a because we know the a value. So a value is minus 1 by 4. So we get b equal to 1 by 4. Substitute a, b, c value, we get this equation. And I split this here. See, there are two terms. So I split this equation in two terms. One is 1 by 4 into z divided by z square plus 4 plus 1 by 2 into 1 divided by z square plus 4. So capital F of z divided by z, taking z opposite direction, we get this equation after taking z inverse on both sides. So z inverse of capital F of z equal to minus 1 by 4 z inverse of z divided by z plus 2 plus 1 by 4 z inverse of z square divided by z square plus 4 plus 1 by 2 z inverse of z divided by z square. Now substitute the suitable formula. So this full value is minus 2 power n, and this value is 2 power n cos n pi by 2, and this value is 2 power n minus 1 sin n pi by 2. Okay. So that is our f of n equal to minus 1 by 4 minus 2 power n plus 1 by 4 2 power n cos n pi by 2 plus 1 by 4 2 power n sin n pi by 2. This is our required solution, or 2 power n by 4 is taking outside commonly, we get the solution. Okay. So this is the procedure to solve the inverse Fourier sine transform. I hope you are all understand for the inverse Z transform, how to solve inverse Z transform, and how to use the suitable formula in the Z transform. Okay. So in this inverse Z transform, we discussed some problems.